Question 20. A certain positively charged meson, denoted M-, is known to carry a total charge of -e. Experimental evidence shows that it contains a strange quark together with one other quark or antiquark. Which particle could be the second constituent of the M- meson? Now, this is a problem related to particle physics, testing our understanding of meson structure and quark charges. So, let's begin with what we already know. We know that mesons are hadrons made of one quark and one antiquark. This means a meson must always contain exactly two constituents, one quark and one antiquark. Also, the total charge of a meson is the sum of the charges of its constituent quark and antiquark. Again, up-type quarks, which are the up, charm, and top quarks, have plus 2/3 E. Down-type quarks, which are the down, strange, and bottom quarks, have minus 1/3 E. Hence, the strange quark carries a charge of minus 1/3 E. Finally, antiquarks have charges opposite to their corresponding quarks. This means that if a quark has a charge of plus 2/3 E, its antiquark will have a charge of minus 2/3 E. Now let's think through the solution step by step. We are told the meson M- has a total charge of minus E. One constituent is the strange quark, which contributes minus 1/3 E. The charge of the second quark is unknown and denoted Q sub x. The total charge of the meson is the sum of the charges of its constituents. Hence, Q sub s plus Q sub x equals the total charge of minus 1 E. So we determine the charge of the second particle by subtracting the strange quark's charge from the total charge. The strange quark contributes minus 1/3 E. So the second particle must contribute minus 2/3 E. Now we identify which particle has this charge. Since up-type quarks have plus 2/3 E, we know that their corresponding antiquarks must have minus 2/3 E, because antiquarks have charges opposite to their corresponding quarks. Therefore, the particle with charge minus 2/3 E could be the anti-up quark. It could also be the antiparticle of any of the other two up-type quarks, hence it could be the anti-top quark as well. From our options, the right answer is the anti-up quark. This is our final answer. What did we do? We used the rule that mesons contain one quark and one antiquark. Then we applied the rule that the total charge equals the sum of the constituent charges. Since the strange quark contributes minus 1/3 E, we determined the charge needed from the second particle to reach the total charge of minus 1 E. This required a charge of minus 2/3 E, which corresponds to the anti-up quark. To summarize quickly, mesons are quark-antiquark pairs. They always consist of one quark and one antiquark. The total meson charge is the sum of constituent charges. Consider the signs of each quark or antiquark in the sum. Also, a strange quark has a charge of minus 1/3 E. Finally, antiquarks carry opposite charges to quarks.